Well, that was pretty sweet, and thanks for tuning in to the Daily Space Weather. Today, the story of the day is filaments, sector boundary crossings, and a slight downtick in overall solar activity. We'll cover lots of analysis of various things here at the Smash News Network, least busted name in news. We will slap your space weather and Earth weather together. This is the past 24 hours in ionized helium from the Solar Dynamics Observatory. And you may notice some rather significant filamentary activity happening down there. There's also a Hyder flare. You see this brightening happening right here. That is a Hyder flare as plasma splashes back down toward the solar chromosphere, the layer in between the photosphere where sunspots occur and the corona, which is primarily what is shown in this imagery. So again, the story of the day is filaments. There was a coronal mass ejection associated with that. We'll talk about its likely direction later. We do have some more active regions also rising here in the eastern limb. That's why we're showing that footage. Looks like 2 new active regions about to rise here in the next. Looks like the next about within 12 hours for one of them. Maybe a little bit longer for the other one. Here's the full disk view in this same wavelength. The classic 304 angstroms wavelength. And we're also going to show 193 angstroms along with 304. That's one of the species of ionized iron, and it helps to show some additional contrast and extended corona. So that's why we like to show that. Here is the northern hemisphere. Again, a slight downtick in solar activity. The Getty Lee filament remains intact. There's another huge filament behind it. Maybe that ought to be known as the Alex Lifeson filament. I don't know. It doesn't look like a treble clef, but it is behind that bass clef looking filament. Looking like a backwards S. Actually looking more like a question mark now. And our question to you is, will that soon lead to an Earth-directed coronal mass ejection? Fingers crossed on that one. Let us know in the comments what you have to say about it. There's the equatorial view. Again, these are all 24-hour videos, typically what is featured in our custom Helio Viewer movies. We show them daily. And there's that awesome southern hemisphere where we had this solar polar vortex feature happening, a coronal mass ejection, Hyder flares, plasma reorientation. Some of that filament is actually still intact down there. We'll show updated images in a bit. There's a great close-up of that filament. And you'll see a brightening near the solar surface there. That's called a Hyder flare. That's when material stops defying gravity. Magnetic fields drop away, and the solar plasma drops down toward the solar chromosphere. All right, let's take a look at sunspots briefly here before we move on and blast through a whole ton of additional information. Here is, that's yesterday plus today. A little bit of growth in that northern group. Besides that, most of those groups largely stable. I would note one important thing. The likelihood of solar flares is going up big time as this magnetically complex group approaches the northwestern solar limb. So likelihood of large solar flares is actually going up here. Let's take a look at the magnetogram for yesterday plus today. Nothing super exciting going on there. I don't see any new sunspot groups to get named, but we'll do a further analysis of that a little bit later. By the way, today's featured product is Forgive, Remember, and Hold Accountable. Back in 2021, we released this design because we were expecting a year of accountability following 2020. How did that work out? Let us know in the comments how that worked out. We were expecting a year of accountability, not a year of incompetence. However, keep in mind, folks, that holding a grudge is similar to ingesting poison and expecting the other person to die. Don't do it. It's a really silly idea. Forgive, remember, and hold accountable because, well, today's activities dictate what will happen in the future, right? So don't dwell on the past. However, plan for the future. a lot of folks demanding accountability right now, and we're one of them. We've got 3 separate designs with 3 different color schemes here. With the Forgive, Remember, and Hold Accountable design, you can find our Redbubble shop linked below this video, as well as on the homepage at smashomash.com. Today's featured product on the the Hemp Lucid affiliate / sponsor is the Full Spectrum CBD Lip Balm 3-pack in vanilla. It's my favorite flavor. And keep in mind, you can use this for stuff besides your lips as well. You can use it for things like your cuticles. It also comes in peppermint cherry. And, well, we have it in an assortment pack, but maybe they're not making an assortment pack anymore. But it makes great gifts. The CBD lip balm, just don't leave it in your hot car. Although it will protect your lips from the hot sun. The Full Spectrum CBD Hemp Lucid Lip Balm. The Hemp Lucid shop is linked below the video. So check that out. Don't forget to enter the promo code SMASHOMASH on all of your Hemp Lucid checkouts. That'll save you 10% on your order. Thanks to everybody who's picked up product, as well as all of you nice folks like Vanessa over there at Hemp Lucid. Today's featured product on the Amazon shop, and you can find that below the video as well as on the homepage at smashomash.com. The Amazon shop is amazon.com/shop/smashomash. Today's featured product is magnesium. Yeah, some people take it as a sleep aid. Now, of course, it's very important for other things as well, like bone health. However, it's also important for muscle health. So we recommend taking it before bedtime. Don't take it with calcium. Just take the plain magnesium, as the calcium and magnesium will affect each other's bioavailability. So you're better off taking the magnesium by itself before bed. Take the calcium at some other point in the day if you're taking calcium, period. But the magnesium, many people report that it helps them sleep. And for me, I'm super sensitive. Being a pro cyclist, I'm actually a living laboratory. So magnesium makes me drowsy. So check it out on the Amazon store, amazon.com/shop/smashomash, and let's see what volcanoes are erupting on planet Earth as we get back to our daily space weather content. There are no volcanoes blowing volcanic ash into space, at least not from Earth today. Jupiter's moon Io probably is, or it might be. Subanose Jima is erupting on Earth. It's producing a 7,000-foot plume of volcanic ash. Flight level 070. Shout out to all my pilot friends on places like Twitter. Haven't seen any of your tweets for a while because, well, the social media platform is completely broken and pathetic. Mount Mayon is also erupting. It's producing unknown volcanic ash plume. Please do not fly your hang glider or home-built kit helicopter over the caldera on the Philippine volcano Mount Mayon. Ibu also exploding. Flight level 060. It's a 6,000-foot ash plume over Halmahera. Dakono, also on the same isle of Halmahera, Indonesia, exploding. Flight level 070. 7,000-foot ash plume. 22,000-foot ash plume down in Colombia from Nevado del Ruiz's explosive activity. It's a flight level 220. Not sure about Sangay. Don't assume it's not erupting. Same thing with Revenador. I suspect it's cloudy over Ecuador. Volcanic ash not observed in satellite imagery. Sabancaya exploding, flight level 240. It's a 24,000-foot ash plume. And also Ubinas, probably cloudy there as well. Unable to detect if Ubinas is erupting or not. Next global seismicity, here are the past 90 days. And let's check the past 24 hours here. There was at least one large quake. And we will cite quakes of a 5 magnitude or larger. So, kind of calm here for the most part for the past 24 hours. However, there was a 5.4 south of Tonga. And these are aftershocks, folks. There was a 7.2 there several days ago, and that area is still in seismic unrest. Aftershocks. That was at 0:58, 2 minutes before 1 a.m. this morning on June 25th. About an hour later, there was a 5.0 at the Izu Islands of Japan. And then a 5.3, a great example of a small, well, not really a small, a significant foreshock, and then a 5.3. Looks like that might have been the main quake. And then later we had a 4.6 in that same location, or close by. Next is 6.0. This is the largest quake of the past 24. That was at 7:16 Universal Time this morning. At quite a shallow depth there, even shallower than 10 kilometers there, listed at 7.1 kilometers. And then yet another smaller aftershock, a 5.4 at 8:26 Universal Time. And let's get back to space. So here are some other wavelengths that we like to show on the channel. 171 plus 211 angstroms. 211 angstroms shows the extended corona and coronal holes. 171 angstroms shows the lower corona. And they're both species of ionized iron, but it's great to see how differently they behave in the solar environment. Keep in mind there's a rich chemical soup going on there in the atmosphere of the sun. We're looking at only very specific portions of the electromagnetic spectrum. The extreme ultraviolet portion, that's what the AIA instrument is looking at. Again, we really like these wavelengths because they show great depth for all the way from the lower corona all the way to the extended corona. And you can also see filaments like that berserk filament reorientation, CME, and collapse in the lower left. You'll also see it in 171 angstroms. And a quick reminder that there are new active regions about to rise here. One is quite close. In fact, by the end of the video, it might already be up. We'll take a look before we close this video out. So next we're going to move to coronal holes, but let's get through some additional solar stats first. The 10.7 centimeter radio flux, it's dropped all the way down to 160 solar flux units. There is the 1-year graph to put that in context. And just as we forecasted, you can see that the sunspot number reached 200 there. And let's take a look at the Space Weather Enthusiast dashboard. The red line is the sunspot number, the black line is the 10.7 centimeter radio flux. So there's a Space Weather Enthusiast dashboard. No geomagnetic storm or geomagnetic unrest conditions forecast. We may see a little uptick in activity in a couple of days here from a coronal hole that's rotating in. We'll get to that here momentarily. NOAA not forecasting any CME impacts or coronal high-speed winds or anything like that. Same with NASA. And here is Earth's magnetic moment from space for the past 4 hours. We did see a brief period of a mild geomagnetic storm. It showed up at the beginning of the day today. However, it was more like at the end of the day yesterday. It just kind of crossed over to midnight there. Again, that's the last 4 hours of Earth's magnetic moment from space. It is geomagnetically calm conditions, everything looking pretty normal. Next, the ground magnetic perturbations map. And you may see some auroral imagery. We barely see any of it because, again, the algorithms on Twitter are entirely broken. However, you might see some. If you do see some, make sure you tag us in the tweets. We will gladly share your imagery if you've got your own. That's the past 4 hours of Earth's magnetic moment from the ground. It shows the most likely places to see the aurora. Also pipeline, railway, and power grid induction. Next, KP index currently at 2. KP2 is the current geomagnetically calm situation. Again, we did briefly get into a G1 KP5 geomagnetic storm condition. It was very short-lived. In fact, it was over by the time it was rated. So, and here's what I'm talking about. Looking at the real-time solar wind, this KP5 situation was actually entirely caused by this section right here. That was the only major change. A great example of how the magnetic field alone can make a huge difference in the KP index. The main feature that caused that was this strong negative BZ signal. That red line there in the negative territory is a reference to the vertical component of the magnetic field. When we see a strong negative BZ, we see a lot of current induced into the Earth system. When we see a positive BZ, it's more of a push as opposed to an induction. That's the feature. And so the total field there did get up. I was watching this last night. It got up to 12 nanotesla. Then it dropped down to 10 nanotesla, but we had a 10 nanotesla field with a negative 10 BZ. So that was a very strong southward vertical component of the magnetic field, and that is what caused the geomagnetic storm conditions. And as you can see right here at midnight, they subsided. And that is why the geomagnetic storm condition only lasted for that one bar. Those bars represent 3 hours. And really, this was over before it started. Well, it did last a little bit. It lasted the first hour. So, but the other 2 hours there depicted by that bar were not very likely to include geomagnetic storm. Now, we did have some questions yesterday about CME impacts, and there were some minor CME impacts. Actually, this is associated with that too, because you've got this little strike right here. You can see changes in the plasma temperature, and then it subsides. So these are all features of glancing blows, magnetic fields moving past the Earth system, and very limited particle interaction. So that's the real-time solar wind analysis. And let's move on to magnetic data. There are your GOES magnetometers, and Earth has, once again, as forecast, moved into a North Pole current sheet, rather. And we're getting excited about the North Pole current sheet. We'll talk about that next. And some of these wild variations here are the CME impact. Some of those are the sector boundary crossing. It's just happened in the past few hours, at least in the past 24 hours. Here, if you look at the latest image, Earth is, it's just happening. So Earth is likely in the North Pole current sheet, but it's just occurring now. So you may see some variations continuing to happen here in the GOES magnetometers. But in any case, that is the past 4 days of the heliospheric current sheet. And what's super important about this, folks, is, well, it's getting exciting because, so there's the latest image, and this is the most important feature on the sun right now. That's more important than sunspots. And it's a coronal hole that's still hanging out at the north heliographic pole. So this is going to suddenly snap down toward the solar equator, and when it does, we can expect to see a big uptick in solar activity. So far, it's still hanging out at the north heliographic pole. When it does snap down toward the equator, expect another major solar uptick. Now, as the sun rotates around, as you can see here, of course, that is rotating toward Earth. We are hoping that this coronal hole moves while it is on the Earth side of the solar disk, because we'll be able to observe it. Plus, it'll be totally sweet to be able to see the solar uptick. Is there a relationship between coronal holes and sunspots? Let us know in the comments what you think. Of course, there is an obvious relationship. I won't get into it at this point. This isn't a heliophysics video. It's just the daily space weather. So here's our line of sight field plot, and you can see that sector boundary crossing shown in blue. That's the sun's B field. And that is, as you can see, rotating in toward the west, as Earth is in the process of entering, or has just recently entered, the North Pole current sheet. So next to our line of sight coronal hole plot, and you can see North Pole oriented coronal holes rotating in here. And we're starting to get a glimpse of the most important one at the moment, because it's part of the solar cycle. It's still hanging out there, very close to the North Pole. It needs to come down here toward the equator before we can declare solar maximum. Until then, we'll just keep stating facts. And let's take a look at coronal holes from SDO. So there is the SDO view. You've got North Pole oriented coronal holes over there in the east. You've got South Pole oriented coronal holes in the west, as you can see there. So the boundary crossing is right about here. These are South Pole, and these are North Pole. So that's what's going on as far as sector boundary crossings go, and let's move to sunspots. I guess they're kind of important, right? So again, we've seen a little downtick in solar activity here in the past couple of days. Radio flux has dropped. Sunspot number might drop a little bit as well, but we're expecting a big showing from the North Pole current sheet. So now this massive conflagration of sunspots has been, I think, entirely South Pole current sheet. So, of course, this does play into the overall solar statistics. We're always interested if there's some sort of a disparity between activity in the north versus the south, whether it's the heliographic north versus south or the magnetic polar north versus south. These are just as important as each other. I'll just say that's a lot of sunspots. Let's take a look at some sunspots here from our SDO perspective. There is 1600 plus 1700 angstroms. 1600 angstroms is ionized carbon. 1700 angstroms is a continuum. It doesn't show any specific chemical spectra. But it does show some great features. Those active regions well highlighted. And let's move to the SDO continuum. So the SDO continuum is just basically full spectrum light there. Again, a little bit of growth in this northern sunspot group, but besides that, things rather stable for the past 24 hours. The amount of time depicted in this video. I would also note that the likelihood of an X-class solar flare is going way up as these groups approach the northwestern limb. Continuing on to energetic particles and solar flares. No energetic particle events have happened for a long time. We did have an M-class flare in the past couple of days, but there is actually an M-class flare yesterday. But overall, it's been, well, again, we've had declining solar activity for the past about 24 hours. So we still are close to a C-class background level. I mean, if you look at the one-day graph, these background levels there, they're like B 9.45, C 1.08. So it's the sun's trying to decide if it's a B-class X-ray output or a C-class X-ray output, but it's right around the line there. Keep in mind those are orders of magnitude. Remember, folks, a C-class, a C1 flare is only 1/10 the power of an M1 flare, and an M1 flare is 100 times the power, the flux density, I should say, of a B1 flare. Let's take a look at our favorite wavelengths for solar flares, which, please bear with me, I have failed to put those up. How do you forget to put up solar flare imagery? Well, it's because when you're doing 4,000 things at once, you'll find that it is easier to do 3,999 things at once than 4,000. Anyway, here is the 94 angstroms wavelength from SDO. Another one of the species of ionized iron. And here comes yet another ionized iron species. This is SDO 131 angstroms. All right, space, a frontier. These are the voyages of a bunch of facts that are not sprinkled with a bunch of nonsense. These are just facts. And we're big on those here at the Smash News Network, least busted name in news. Here are some facts about what's going on overhead. So that's the current situation over Lehigh Valley, PA. If you want to make your own star chart, try skyandtelescope.org. I like it. Otherwise, I wouldn't be showing it to people like you. And as we've been saying for days, if you're looking at the shortly after sunset skies, you might see Mars, Venus, and the Moon all up there at once. Some of the brighter objects visible from planet Earth there. And let's move on to a solar system forecast. So we've got Mercury getting pretty close here to an Earth-Sun conjunction or opposition or whatever it's called in the realm of astrology. Here is your 1 week forecast. And we hope you're enjoying the final bits of June. Yes, there's where things will be on July 2nd. We will have a gibbous waxing moon by then. And Mercury will be quite close to, it'll be slightly past, actually, its opposition or conjunction or whatever the hell it's called. All right, so if you enjoy the content, don't forget to press like and subscribe. Thanks to our new subscribers. Congratulations on realizing the channel exists. Frankly, we're surprised with the pathetic state of affairs with censorship on big tech platforms. And remember, folks, there is no alternative to a monopoly. Do not tell me to go on Rumble or Library or any of these other nonsensical sites. They do not have 1 billion daily users. YouTube has over 1 billion daily users. So there's that. Also, if you haven't seen our shorts, if you've got people who have like 15-second attention spans, go check out our shorts. Also, a little tutorial about what to do with the YouTube channel. If you haven't seen the community posts, who knows? Who knows what you're able to see if you're able to see anything? Check out the community posts if you haven't seen those. We've got, of course, different information there that is exclusive to the YouTube platform. So we hope you are able to see those. We hope you've pressed like, subscribe, share, etc. Leave us a comment. Tell your friends and foes about us. We need your assistance getting the content onto screens because, well, certain organizations don't seem to be recommending it, even though it is by far the industry leader for daily space weather. Good luck finding a channel that has anywhere near the capabilities that our channel has. And to all you other space weather, daily space weather types, good luck. We do need more people on the job instead of less. Here are 97 frames of CMEs since yesterday, and there was a big CME associated with that crazy filament eruption that we showed you to start the video out. It happened right before midnight, so you're not going to really see it in this imagery. However, in the 38 additional frames from today, there you can see it, whoops, making its way out of the southeast. I don't anticipate that having any earthly directed components. It's to the southeast of Earth. And we'll look at some more coronagraphs here. Here is some more data from Soho, Lascaux C2 and C3. Little CME there off to the northwest as well. And there you can see Mercury peeking into the frame on the C3 on the right. We'll also show stereo A. That is a diagram of the locations of stereo A for today. We keep showing it because, well, stereo A and B are way too close to the Earth right now to provide any particularly interesting information. Now, keep in mind the time and date stamps there, folks. These are not synced. There you can see that on stereo A, that's CME to the northwest. That's not likely to be earthly directed. And you can see Mercury peeking in on the right side there on the Soho, Lascaux C3. And then you'll see this CME coming out of the southeast. Just pay attention to the time and date stamps. Again, those are not synced. And let's move on to our custom coronagraphs. So there's a 24-hour coronagraph composite. That is SDO 193 angstroms, yet another species of ionized iron. Here's a slightly closer zoom. You can see that plasma reorientation happening there. In the lower left, the southeastern limb of the closest star. Here's an even closer view of that. You can see that brightening happening. That's what's called a Hyder flare, a type of secondary solar flare associated with plasma reorientation as it succumbs to gravity and splashes back down toward the solar surface. Anyway, there's just 193 angstroms by itself. And what else do we have for you today? Plenty else. And back to filaments. Now, as I said to start out the video, filaments are the story. We've seen an underperformance of both solar flaring and coronal mass ejections. So the Getty Leaf filament is definitely a good candidate to produce some coronal mass ejections. What about this one? Is that the Alex Lifeson filament? Let us know in the comments what you think. Although, if you want to actually name filaments, you'll have to do it on Twitter. So, sorry, and if you've unplugged entirely from social media, I don't know how you're watching this video, as YouTube is indeed interactive, which makes it social media, but hey, maybe you're only watching the videos on BitChute, which means you're missing like 98% of the content. Anyway, large plasma filaments are currently on the Earth-facing portion of the solar disk. More are rising in the east. We've got two major ones here. That one there the one east of the Getty Lee filament, could perhaps use a name. Again, if you want to name filaments, make sure you do it on Twitter. We won't accept naming of filaments because we're trying to get people to follow the Twitter account, because there's all kinds of additional shares and things that you'll only see on Twitter. So things like auroral imagery. And by the way, if you want to share content with the channel, that's a place to do it. You can send DMs on Twitter. You can send DMs on Instagram, another place where you could theoretically get your own imagery on the channel. If you've got something interesting to share, like auroral imagery or, I don't know, imagery of the moon or whatever, we will consider it. Again, Instagram is another place to follow us if you want to see more things like fitness and lifestyle posts. You want to see daily incentive on not to crash your bike. Yeah, there's an image of my jersey from yesterday. And let's take a look at the last couple of hours here from the closest star. There is the view from the GOES 18 SUVi. So massive prominence is here rising. There's at least one likely new sunspot rising right here. I don't think it's over the limb yet. So, again, very high likelihood of large solar flares coming, especially to this region. Don't be surprised to see an M or even an X-class flare. We'll keep our fingers crossed, and let's move to bonus features. So here's our bonus features segment. We're starting out with satellite charging hazards, and we do have some minor surface charging hazards here in the Eastern Pacific. So keep in mind, folks, satellites, they do not like any sudden changes to their environment. When the ionosphere puffs up, it creates satellite drag, and it can even pull satellites down and crash them. This will typically cause satellites to have to change their orbit. These surface charging hazards are simply caused by low-energy electrons that'll build up on the outside of the spacecraft and can cause some minor communications breakdowns. There goes electron flux here. I suspect it's not going to get back into warning levels today, as this electron storm has been lasting for quite a while. That's the past 3 days. The radiographic measurements from the GOES 16 and GOES 18. There's the one-year graph to put it in context from Solon.info. That is just a moderate range of relativistic electrons that are measured at the F layer of the ionosphere. There's the forecast model, and it looks like NOAA is expecting essentially flat levels here. I would expect a slight downtick, but hey, that's me. Anyway, the F layer of the ionosphere is what we'll show next. It's at about 300 kilometers of altitude. Feel free to pause the video on this frame if you're not familiar with things like the penetration of electromagnetic radiation into atmospheric layers, temperature inversions, and chemical compositions. So here is the vibrational frequency of the F layer. We are seeing some anomalies here of the low frequency variety in the northern hemisphere, which is what you'd largely expect when you've got a minor CME impact. But they are very minor anomalies here, so you might be able to see them from this imagery, or it might be all Greek to you. It's showing millions of vibrations per second, otherwise known as megahertz, of the very diffuse gas at the bridge between Earth and space. It's courtesy of the Australian Government Bureau of Meteorology. Here's the anomalygram. And there you can see those low-frequency anomalies in the northern hemisphere I was talking about. Keep in mind, it is summer up here. So that does cause a disparity, as the incoming solar radiation is skewed toward the northern hemisphere by something like 23 degrees. So that's the anomaly in megahertz from a 30-day median. And we'll briefly show the latest image, which is 11 o'clock Universal Time ionogram and 11 o'clock Universal Time anomalygram. We also like to show the total electron content. That's free electrons to about 12,500 miles of altitude, the location of your GPS satellite, the approximate location of your GPS satellite. So this will show you the most likely places to see GPS errors. If you're expecting your GPS to have huge errors, why try the Wi-Fi location accuracy? That's a feature of my Android device, at least. And by the way, I'm not endorsing Android devices. They barely function because the writer of the software, Google, is terrible at writing software. However, they do have a Wi-Fi location accuracy service, which allows the system to use the proximity to Wi-Fi hotspots and their known ground-based IP locations, the geographic locations, to send that data to your location services. Anyway, that's a total electron content. Here is the North American anomaly from the 10-day average. We are seeing some rather significant anomalies here around southern Mexico, Central America, and it looks like northern South America. See quite a bit of red there lighting up there. Also a little bit in the Caribbean. That is the total electron content anomaly from the 10-day average. High electron counts are shown in red and low electron counts are shown in blue in this imagery, by the way. I would have picked a different color scheme, but hey, that's the scale. Here's the latest intensity gram and the latest SDO magnetogram. Now you're looking at the photosphere here, so don't get these magnetic fields confused with coronal hole magnetic fields. They are different layers. And the sun's magnetic fields vary drastically between the photosphere and the corona. Anyway, do we have any new sunspots on the eastern limb? I don't think so. Although I do think that is a new one right up there in the north. So did that one actually recently form? That one right there, I don't remember seeing that one. Did that rapidly form? It looks like there's another one there also to its southeast. Let's go back to one of our... I'm going to go back to one of our videos here. So I think that one's already named, but this one down here might not have a name yet. Anyway, just wanted to cover that there because I didn't see that before. Oh, that's actually a degrading. So this sunspot has just degraded since yesterday. Anyway, that's the situation. Just to reiterate one more time here, the most likely place to see a large flare, in my opinion, is up here in the northwestern limb. And don't worry, we'll be monitoring it all day. And let's get out of our bonus features segment and move to meteorology. So now what we're interested in is wave chasing. So these are the world's surface winds and largest waves, and it's quite calm here on planet Earth at the moment. The seas are calm and there aren't really a whole lot of high winds. The strongest winds are right there in the Southern Ocean, only about 56 miles an hour, and the waves are about 30 feet there. Probably nobody around there to experience those. Not a lot of traffic in the extreme southern Pacific, the border between the Southern Ocean and the South Pacific. That is a desolate portion of the world. So if you go around and look at the rest of the winds and waves, that's it. That's the most violent weather as far as seafaring goes. Even this tropical system in the Western Atlantic is looking weaker than clock radio speakers. Shout out to the Jizza of the Wu-Tang Clan. I did not write that rhyme. Weaker than clock radio speakers is his. I give credit where it's due. Anyway, let's move to regular weather. As you may not all be wave chasers, but you are slaves. Slaves to temperature and pressure and humidity. These are the surface winds of the eastern world. And let us know how many slaves you think are in this portion of the world. Is it only 2 billion or is it 3 billion? Let us know in the comments what you think. Here are the jet streams of the east. And we hope you're not enslaved. Universum libertate is what I have to say. If you are enslaved, universum libertate. Check our Redbubble shop to join the Galactic Federation. Anyway, there is the jet stream scenario for the West. We've got a strong jet stream about to the Mississippi Valley, and then whoops, a huge divergence. And an anticyclone here over New Mexico and Arizona. Great example there of an upper pressure high system. You can see that clockwise rotation. An anticyclone. Did you know Jupiter's Great Red Spot is an anticyclone? Some people think it's a storm like a hurricane, and it's the exact opposite. Some people think hurricanes are like a sunspot. Those are the exact opposite. There's a lot of nonsense on the internet from ignoramuses who don't understand physics, trying to teach people about physics. It's pretty Those are the surface winds of the Western world. These are the surface winds of Europe, Africa, and the Middle East. Or Central Asia, if it's not politically correct enough to call it the Middle East. And those are the jet streams, still blowing backward here over the northern portion of Africa and the Indian Ocean. Also, the Bay of Bengal, featuring a backward jet stream. Does it mean the world's going to end? Well, no, I'm not scared in any way of backward jet streams, and you shouldn't be either. It is completely unscary. And let's take a look at a drought map. So the drought has been subsiding over the U.S. here, the central part of the country there, getting some rain, and the U.S. is almost lacking extreme droughts. That's a good thing. Although a little bit in Iowa, Missouri, Kansas, and Illinois. Also a little bit in Indiana there, but the droughts have been subsiding. Sorry, it's good news. It's not gloom and doom, folks. I know if it bleeds, it leads, but facts trump alarmism. Here's the clouds and fog scenario over the Western world. People probably think Brazil is using harp rings to control the weather. That's pretty pathetic. So many fictional things are believed. Did you know more people believe the Earth is flat now than did 2,000 years ago? Yeah, a lot more people think the Earth is flat now than they did 2,000 years ago. Mainly just because there are a lot of people on the planet right now. There are a lot of people who can read nonsense on the internet and believe convincing-sounding charlatans about all kinds of ridiculous science topics. That's clouds and fog over croissant Earth. Next, our weather.gov map. We've got some air quality alerts there in places like Maine and Minnesota, some extreme temperatures in places like Texas and other Gulf states. Also southern Arizona there and southern New Mexico. Also some gale warnings around Hawaii and Alaska. If your location is lit, just click your location on weather.gov, the official website of the National Weather Service. Here are some forecasts. And we're starting out with temperature anomaly. We hope you're not a slave to temperature. Temperature, yes, it's almost as scary as pressure. Pressure is almost as scary as humidity, except that it takes all three to create a thing called weather. Did you know that all of your weather occurs in the troposphere? Yeah, one tiny layer of the atmosphere. The layer below the mesosphere and stratosphere, the troposphere. There's a lot of material in the troposphere. Namely nitrogen, and then water vapor. Don't forget oxygen. Anyway, so that's the situation for temperature anomaly forecast. That's temperature anomaly in degrees Celsius based on a 72-hour GFS model. Texas, it's going to get hot and stay hot. Next, your smoke forecast. That's your smoke forecast from firesmoke.ca. Firesmoke.ca is the URL. Our Canadian smoke map animation. See a large cloud of smoke here making its way all the way down toward Cincinnati, Indianapolis. Expecting some fairly significant smoke there. Expect to see great sunsets and sunrises. I like when it gets smoky here in Pennsylvania. It makes me go out and ride giant mountains. I like extreme temperatures, whether they're cold, hot, all the extreme conditions. Bring them on. Here's your jet stream forecast. That's your 72-hour GFS, 250 millibar wind speed analysis. And the jet stream here is going to sort of make its way through the U.S. here. That's a fairly normal-looking jet stream there in a couple of days. That huge divergence will end with a more complete jet stream right across the center of the U.S. And we'll also show pressure and precipitation based on the same model, the GFS 72 hour. Some strong storms here coming to most of the east. A whole line of storms there stretching all the way from Quebec to Florida. And let's move this thing on. We don't want it to be too lengthy. There is the GOES lightning mapper. Those are the likely places to have seen lightning for the past about 10 hours. And did you know about our mission? Yeah, we're in the process of forming a nonprofit science foundation called smashomash.org, where we will advance science via heliophysics. Did you know that superionized materials are not only the future for cosmology and astronomy, but also the future for human technology? Help us out by becoming a member of the SMASH team, if you haven't already done so. Join up over at smashomash.com/SMASH team, the official subscription services site of the Smash News Network, least busted name in news. So join us over there if you want additional content. We created our own website because we needed additional capabilities. There is a bronze level, which will cost you nothing per month. It'll be $0 per month. The silver level is $2.99 a month, and the gold level is $9.99 a month. There's also a gold annual paid-up subscription, which is actually the best value. It's like getting 4 months of a gold membership for free, as it includes complimentary merch. Smashomash.com/SMASH team for additional content. Join us there. More information about the upcoming procedures. You can find links at smashomash.com. And welcome to the Neo-Renaissance, as there is some important stuff about to happen in the realm of heliophysics, astronomy, and cosmology. And don't forget human technology. It's pretty serious, and it's going to be an interesting decade, to say the least. Now, where did my real-time lightning map go? What the heck? No real-time lightning map. That's unacceptable. We show this on the regs. Lightningmaps.org, folks. Lightningmaps.org. And we do have a little bit of lightning here around Louisville. Louisville, there is lightning about to be there. That is a pretty heavy storm, too. Those are a significant number of strikes. The possibility of some damaging wind or hail may be there. It looks like a severe thunderstorm to me. Here's your full view. And let's close this thing out. We don't want the video to be too lengthy. There is your Doppler for that same area. A line of quite concentrated storms there. They'll be short-lived, but they'll be severe. Here's a full 50 state view. And we'll focus on the lower 48 to close this thing out. There is clouds and fog depicted by 3.9 micrometer infrared radiation. There is the water vapor map. It's looking clear over South Carolina, and it's looking clear over New Mexico. Here's your recap. Vertical motion in the air column, U.S. Doppler radar. 3.9 micrometer radiation from the NASA GOES interactive weather satellite. And there is water vapor. And this recent rain here is caused by a compression. You've got high pressure air moving from the back. It's also a little cold as it's coming down from Canada. And then you've got this blocking feature, another high pressure zone. This is a relative low, and that's part of the reason why it's short-lived. It's being compressed. And hopefully your content is being compressed into content that is useful on YouTube. Anyway, thanks for tuning into the Smash News Network, least busted name in news. Because I've seen all this scary, spooky stuff when it comes to Earth and space weather, it's time to head back to the bunker. So good luck with you. We hope you have a bunker. We hope it's as good as Jeff Bezos's, and we hope it's just the right depth, folks, just the right depth. Anyway, see you soon. I may peek out and make another video. In the meantime, may that solar wind be at your back. Bye! Whoa!